Welcome to section B.3. This is solving rational equations. So we just finished up with graphing and finding a lot of different characteristics about rational functions. Now we're going to solve rational equations. So given a rational equation, how do we solve it? Well, we really don't want the denominator there. We want to somehow get rid of that by multiplying. So the first thing to do is figure out what those factors are. So number one is to factor the denominator. So we're going to factor the denominator. So x and x minus 2 are fine, but then x squared minus 2x, you can factor out the GCF of x. So we're left with x and x minus 2. So we factor the denominator. Step 2, you can actually do this at the end, but at some point you need to determine what those excluded values are. So now that you have it factored, it's kind of a good time to do that. So we know x cannot equal 0, and x minus 2 cannot equal 0, so therefore x cannot equal 2. So those are our excluded values. X cannot be those two. All right. Step 3, multiply by the common denominator. Once we find that common denominator and we have it in factored form, we can multiply everything through by that and it will cancel. So we're going to take this entire thing here and multiply each term by x times x minus 2. Those are our two factors that we have to have. So I'm going to go down here a little bit farther so we can see all this. So 1 over x gets multiplied by x times x minus 2. Alright, so you're basically distributing to each term in the rational equation, plus 3 over x minus 2 times x minus 2 is equal to 4 over x times x minus 2 times x minus 2. So I'm going to put each of these terms that are being multiplied in brackets so you can see how each of them are being multiplied by that same common denominator. Once you've done that, now you can go ahead and solve. So what you'll notice is this x and this x cancel. So now you're left with 1 times x minus 2, which is just x minus 2. Once again, just going to put it in brackets so you can see each piece. The x minus 2's cancel, so that's left with plus 3 times x, or 3x, is equal to, now on this one the x's cancel and the x minus 2 cancel. So on this one you're just left with 4. So once it's simplified, there's your three terms, and then at this point you want to solve. So we got 3x plus x is 4x. We're going to add the 2 to the other side, so that's equal to 6. Divide by 4, and you get x equals 3/2. Now, this is the answer unless, when we check for our extraneous solutions, this is based on your restrictions. We know x cannot equal 0, and x cannot equal 2. Well, that's not what our answer is. So therefore we don't have a problem with the solution 3/2. So x is equal to 3/2 for this rational equation. Alright, so as we solve these rational equations, we'll have different ones in terms of how many factors and things like that. So let's take a look at another one here. If you want to pause the video and go ahead and give it a try, it's not a bad idea. It's very similar to the first one we just did. So here we go. So we want to factor. So on this one, when we factor, once again, the t and the t minus 4 are fine, but on the last one, you want to factor out the GCF of t minus 4. We notice once again that t and t minus 4 are common denominators. We also know that t cannot equal 0, and t minus 4 cannot equal 0, so therefore t cannot equal 4. And I will once again kind of show this long step, but very important in terms of what things are going to cancel. So each term gets multiplied by the common denominator t times t minus 4. And once again, I'm going to put them in brackets so you can see each term being multiplied by the common denominator. So there you go. So change colors here. The t's cancel. So now we have t plus 4 times t minus 4. The t minus 4 cancels, and that one we just have plus 3t. So once again, just putting them in brackets so you can see where they came from. And then the t and the t minus 4 cancel, so you're just left with negative 16 on that last term. And so now we need to simplify and solve. First, we multiply the two binomials, which gives us t squared minus 16. That'll be plus 3t is equal to negative 16. Since this one is a quadratic, we want to set it equal to 0. So it looks like we will have t squared plus 3t. If I add 16 to negative 16, those actually just cancel. So in this quadratic, we can factor out a GCF, and our two possible solutions are 0 and negative 3. Once again, we have to check against our restrictions. Our restrictions were up there at the top, so t cannot equal 0 and t cannot equal 4. Well, we got t is equal to 0, but because of that restriction, that will no longer be a solution. So our solution to this rational equation is t is equal to negative 3. And for the very last equation, change it up from the first two, have a little bit more going on this one. We still need to factor the denominator. The first two fractions are already simplified and factored. The last one here, we have a negative x squared. I think one of the easiest ways to factor this is to take out that negative 1 or use the distributive property to factor it out. And then that will give you a quadratic that's a little bit easier to factor. So factors of 14 that give you negative 9 would be negative 7 and negative 2. And so you can see we have x minus 2, x minus 7, but now we also have a negative 1. So this whole thing gets multiplied by that common denominator, negative 1, x minus 7, and x minus 2. Alright, once again, restrictions. T cannot equal, I'll do it this way, t minus 7 cannot equal 0, which means t, and I don't know why I did t, let's go back and fix that. How about x minus 7 cannot equal 0, so x cannot equal 7, and x minus 2 cannot equal 0, so x cannot equal 2. So those are our two restrictions on this one, and once again we'll make sure we look at that at the end. So if we multiply, show all my work here again, so I'm going to multiply the term 1 over x minus 2 times negative 1, x minus 7, x minus 2, so that's the first one, minus x minus 3 over x minus 7. That term gets multiplied once again by the common denominator. And that's my second term, is equal to, so I'm going to write this one in factored form so we can see what's going to cancel. And that also gets multiplied by that common denominator. So all the way across there, those are the three terms. And now you can see everything that's going to cancel. This x minus 2, that x minus 2. So what's left? We have negative 1 times x minus 7. So negative 1 times x minus 7. Alright. Minus. Now the x minus 7's cancel. We got a couple things going on here. We have the x minus 3. We still have that negative 1. And we have the x minus 2. So we're going to have to simplify that a little bit. And then negative 1 cancels, x minus 7 cancels, and x minus 2. So everything on that one cancels. You're just left with the numerator x plus 1. Alright, let's just, at this point, you just got to simplify. We'll distribute the negative 1, so that's negative x plus 7. Minus, now before I distribute that negative, I want to simplify everything inside here. So it'll be negative 1 times, I'm going to take the x minus 3 times the x minus 2, so that'd be x squared minus 5x plus 6. Is equal to the x plus 1, and so once again negative x plus 7 minus, one more simplifying, I'm going to distribute the negative now, negative x squared plus 5x minus 6, and then now at this point, and maybe even leaving this in brackets so we don't get it confused with that minus sign, now we can distribute the minus, so now it's negative x squared, which is positive x squared. Distribute the negative to the positive 5x, and distribute the negative to the negative 6, which makes it plus 6. And so now we can set it equal to 0. You can see it's a quadratic and we can solve. So if we simplify, we got x squared, we got negative x and negative 5, so that's negative 6x. 7 and 6 is 13. And then subtract the x would give you minus 7x, and subtract the 1 would give you plus 12. And if we can factor it, I'm going to go ahead and factor it. So that looks like we could do x minus 3 and x minus 4. So that'll give us two solutions, or two potential solutions. So that'd be x equals 3 and x equals 4. Don't forget about our restrictions from above up here at x cannot equal 7 and x cannot equal 2. You can see that this one is not going to matter. So our solutions are x equals 3 and 4. And I can show you how to check your answers on the graphing calculator in class.